Today we are going to study about advanced abrasive finishing processes, wherein this is a particular sector of the abrasive processes where you will see the advanced versions and you will do the finishing of complex surfaces as well as the simple surfaces also. Okay. So, what is the need of advanced finishing processes? So, conventional finishing processes such as grinding, honing, super finishing, lapping, these are all you have seen, and we move on to the advanced machining processes where the MRR or the material removal is the primary criteria. Now, we move on to the advanced finishing process where our primary criteria is to finish to the nano level of simple to complex geometries. So, what is the need to reduce the friction? It means that if you are going to get the micro to nano surface finish, or you can reduce the friction, improve the fatigue life. If your surface is very rough, what will happen? The fatigue life is very low, because assume that you have a shaft and the bush. If your bush is too rough, what will happen? Shaft will locate on the peaks of the bush surface roughness, and whenever you are rotating with high speed, what will happen? These peaks will burnish or these peaks will shear off. Then what will happen is that there will be a eccentricity generation and the fatigue life or the other life of that system will collapse. Reduce the generation of crack formation. If the surface roughness is low, it can reduce the generation of the crack formation. If you are using some practical conditions, what will happen? The surface roughness will start initiating some of the cracks. So, if you go for nano finishing, so this possibility will go down. So, eliminates the vibration. If there is too rough surface, there will be always chances for some vibrations in the system. Less susceptible to corrosion. If the surface peaks is like this, what will happen? Whenever you have a flow of certain fluid, what will happen? The valleys will accumulate all the liquid. So, this will initiate the corrosion and other things. Okay. So, the advanced abrasive finishing process, what are the other advantages is that you can do the finishing for the complex surfaces also. This is the small turbine or impeller to be finished. So, initial surface roughness is 1.75 and finally is 0.4 microns. Okay. The most important thing is that you can achieve by the hand lapping also, but at the same time automation is always good. So, advanced finishing processes with computer numerical control system and other things, it will be always good. Okay. So, one can do also finish the knee implants by advanced finishing process, not only abrasive flow finishing process, you can do this finishing process by MRF, that is magnetorheological finishing and other things. So, in particularly this particular section deals with polymer assisted abrasive flow finishing processes as well as magnetorheological finishing processes, and what are the advantages and limitations of the polymer rheological abrasive flow fluids as well as magnetic rheological abrasive flow fluids. We will see these things in deep in this particular section of the course. So, we will move on to the first process, that is called abrasive flow machining process or abrasive flow finishing process. Initially, this particular process is called abrasive flow machining process because this particular process is used for deburring applications in complex features. Assume that there is a junction of two holes or multiple holes. At the junction, very internal holes, 2 holes or 3 holes internally, then if at all there is a burr generation, it is too difficult for any particular person to remove that one. For that purpose, the semi solid type of tools are developed and you just extrude across that section. So, it will deburr that. The deburring is nothing but the machining operation. That is why this particular process, when it invented in 1960s, so it is called as abrasive flow machining process. Gradually people are using it for the finishing applications. That is why this process also called as abrasive flow finishing process. So, introduction to abrasive flow finishing process. Abrasive flow finishing was developed by Extrude Hone Corporation in 1960s in USA. It produces the predictable, repeatable and consistent results because this has that ability to upgrade across the sections uniformly. So, up to 90% time can be saved by using AFF compared to the hand finishing operations. Hand finishing operations are not controlled by the automation. So, at the same time, to get the uniform surface finish, you need well equipped, at the same time well experienced operators. But in abrasive flow finishing, you can go ahead with the automation and you can do this particular process. Principal finishing parameters of AFM are setting parameters, that is nothing but the input parameters like extrusion pressure, number of cycles and other things. Tooling. So, tooling is nothing but how to hold the different work pieces. Medium, that is abrasive medium, or media says that plural. So, you can go for styrene based polymers, you can go for silicon based polymers and workpiece parameters such as initial surface roughness. Produce surface, it can produce surface finish as good as 50 nanometers and debar holes as small as 0.2 mm radius and edges of 0.025 mm to 1.5 mm it can do. The easy to navigate AFM to any automatic manufacturing environment. At the same time, understanding and controlling the process parameters, AFF can be applied to impressive range of finishing process. That means that you can apply based on your requirement to any particular finishing applications. So, normally in a finishing operation, basically the finishing operation will be a final operation in particularly to any type of component manufacture. 15% of the production cost will always incurred in the finishing operation. The cost of surface finish increases sharply from less than 0.1 micron. That means that if the requirement of surface finish is a mandatory for a particular component, then the surface roughness is inversely proportional to the cost. That means that if your surface requirement is nanometers, your cost of the product escalate very high. So, that means that if the roughness requirements are low, then your cost of the product will goes up. So, abrasive flow finishing or the abrasive flow machining produces extremely thin chips, allowing the better surface finish, closer tolerances and generate more intricate surface features also. That means that predominant texturing also people have observed. It can finish hard and difficult surfaces, like whenever if you want to finish the hard materials or hard steels, you can do it. At the same time, automated and can offer better accuracy, efficiency and economy and consistency for producing compressive residual stresses. Also this particular process will be used. That means that whenever you are using reciprocating the medium across the workpiece, that picture you will see in upcoming slides, what will happen, there will be a possibility of compressive residual stresses generation. Some of the papers on abrasive flow finishing also reported that the compressive residual stresses are observed. If the compressive residual stresses are there, it is always good to apply into the practical conditions. If you see the abrasive flow finishing process potentials, uniform radius generation on internal holes can be achieved. Edge or intersection deburring, that is what I said, whenever you have an intersection of two holes internally, then deburring at that location is completely a difficult task for a conventional finishing process. For this particular process, it will be easy because you are going to use a liquid to semi-solid type of tool. Okay, how to fabricate or how to design this type of liquid based tools and other things, we will touch some of the introductions. Surface improvement of irregular and regular shaped passages can be achieved, and the removal of thermal cast layers, that is whenever you have done the process like EDM or laser beam machining, this type of thermal processes whenever you do, what will happen is recast layer will be formed, that we have seen in the previous classes. This recast layer is not good for practical application because it is a brittle layer At the same time, thermal cracks will be there. So, whenever you use into the practical condition, this particular recast layer will goes off, leaving the eccentricity and causing lot of noise and other things. That is why it has to be removed before you are going to put into the practical applications. Produces compressive residual stresses, which we have seen, and this is good for the practical application. At the same time, create or improve liquid flow path inside the valves and fittings. That means that it can be used for fuel injector nozzles and others, wherever the fluid flow is most important, and fluid flow which is to be controlled or controlled fluid flow is required. There you can do the surfaces to the nanoscale and you can achieve a better surface. If you see the AFF process as such, you have lot of elements, and individual elements we will see in the upcoming slides. This is how the AFF process looks like, or abrasive flow finishing process looks like. Hydraulic unit, basically hydraulic unit is connected to the lower hydraulic cylinder, at the same time upper hydraulic cylinder, because there will be a hydraulic fluid to actuate the upper and lower hydraulic cylinders, so that the pistons will move. You can see lower medium cylinder and upper medium cylinder. These are the most important things. As you can see in the next slide also, what will happen, you have a medium cylinder like this. This is your workpiece, assume that this is the workpiece. These are the piston. What it will do is, this is the workpiece, this is the medium cylinder, you just have to fill the medium here. These two pistons will reciprocate like this. That means that the medium which is there in the upper medium cylinder will try to pass through this one and reaches to the lower medium cylinder. Whenever it is reaching, the lower piston will go back to accommodate all the medium and to and fro. What will happen in this way, if you start reciprocating the medium, what will happen, the internal hole or the inner walls of this particular cylinder workpiece will be finished. Okay. So, that you can see here, this is the upper medium cylinder where the medium is there, and lower medium cylinder. The main function is the medium has to reciprocate in this direction. This is the medium on which I am writing the arrow. This medium has to reciprocate, so that the workpiece fixture which is there holding the workpiece will be finished. Okay. For that purpose, hydraulics unit will supply the hydraulic power, which is controlled by a solenoid valve. So, this solenoid valve changes the direction once it reaches to the maximum limit of the piston moving to the top dead center to the bottom dead center, the other bottom cylinder piston will actuate. Okay. So, this in clear way I will show you the finishing region, how it will take place in this one. You can see here the medium is placed in the top medium cylinder. This is the medium, and this is the upper medium cylinder, this is the lower medium cylinder. So, the medium has to transfer, or the medium has to push to the lower medium cylinder across the workpiece. This is the workpiece. Okay. What will happen here is, the medium is reciprocated like this first, then comes back to the original position. This is the upper and lower hydraulic piston. Okay. So, what will happen is, if you are reciprocating the abrasive medium, which consists of polymers plus abrasives and other things, what will happen is, it will reciprocate, and whatever the internal surface to be finished in the workpiece will be finished. Okay. So, hope you understood. I have a upper medium cylinder, I have a lower medium cylinder, in between I have a fixture where the workpiece is fixed. Now, my intention is to flow my liquid type of tool from top to bottom, bottom to up. For that purpose, both the pistons will move up and down like that or reciprocate. Whenever this lower medium cylinder's piston will push the medium flows across the surface finishing zone of the workpiece and reaches to the top medium cylinder. Once the top medium piston or the hydraulic piston will push back, then it will come again to the lower medium cylinder across the workpiece. So, this reciprocating nature of the medium that consists of abrasive particles will shear off the surfaces to be finished in the workpiece surface. So, AFM process, a semi-solid media is utilized which comprises of the carrier fluid in the form of polymer base containing abrasive powders and desired proportion and which extruded it with a given pressure. That is what I have explained, that it will move up and down and the material will be removed in the workpiece region wherever across the surface it is moving. Now, how the material will be removed? Okay. So, for that there will be a physics behind it. So, what we are going to use here is, assume that the finishing region is this particular figure 1. What is here is happening is, whenever extrusion pressure P is applied, you have a medium that is a viscoelastic medium. Okay. This particular ash color is nothing but viscoelastic medium. Okay. This is a viscoelastic medium. Viscoelastic means it consists of viscous component and it consists of elastic component. Okay. So, the viscous component tries to move along the direction of applied pressure. That means that the medium will be pressurized in this direction. So, the viscous component moves in the direction of the pressure, that is nothing but viscous, and elastic component moves perpendicular to it. Okay. Whenever you take a honey or any viscous fluids like water or honey or something, whenever you just throw it with a certain pressure, what will happen? The honey or water flow in the direction of applied pressure. But if you see the eraser, which is made up of polymers, normally erasers that you will use for erasing the pencil written errors and other things, if you stress it, that are normally viscoelastic materials, viscous component tries to move in the direction of applied pressure, but there will be a dimensional change in the eraser in the perpendicular direction. If you might have seen, that is called elastic component. Okay. So, if you see the analysis in the figure 2, what is here you are seeing here is viscous component tries to move. If I am applying a shear force in this direction, the viscous component moves in this direction and elastic component moves in this direction. Okay. So, viscous component gives rise to axial force and axial velocity, and here indentation will give the radial force and radial velocity. Okay. So, if you see here, what is the function of FR, VR, FA and VA? So, elastic stresses, then you divide the extrusion pressure of viscoelastic medium into two. One is the elastic stress which causes the radial force, and indentation of the abrasive particle in the workpiece surface. Okay. So, VR, we are talking about the VR. VR is nothing but velocity of radial velocity. That means that how much velocity the abrasive particle is indenting into the workpiece. Okay. Let me explain with respect to a surface roughness profile. So, I have a surface roughness profile like this. I am having a abrasive particle here. So, my radial force and radial velocity directions are here. So, FR comma VR, and here is FA and VA. These are the two things. Okay, FR is required for us for indentation purposes. But if you see the radial velocity, the velocity at which the abrasive particle is indenting into the workpiece, that will be too less compared to my axial velocity. Axial velocity is nothing but how fast the abrasive particle is moving along the direction of applied pressure. That means that my VA axial velocity is much bigger than my VR. That is why VR is neglected. That means that the indentation velocity into the workpiece is always very negligible. That is why VR is neglected, but we consider the radial force. Along with the radial force, we consider the axial force, then the axial velocity also. So, viscous stresses, if you see the viscous stresses, it will gives the axial force and place indented abrasive particle in the axial direction. At the same time, you will also get the axial velocity also. So, you are getting in abrasive flow finishing three things. One is axial force, axial velocity and radial force. Okay. So, these are the main components for finishing of this one. What is the main function of radial force? Radial force try to indent into the workpiece surface, or it will try to penetrate into the valley and it try to shear the peak by the help of axial force and axial velocity. It will indent because of the radial force and it tries to move in this direction because of the axial force and axial velocity. Combination of this radial force, axial force and axial velocity, you are going to get a microchip or the nano chip, and the material removal will takes place. Okay. If you can see here the forces which I am explaining here. So, this particular slide will explain you about active abrasive particles. So, if your medium is there, at the same time medium will have lot of abrasive particles, wherein very few abrasive particles will take part in the finishing action, because these are all coming in contact with respect to workpiece. So, the yellow ones are active abrasive particles. That means that this is 1, 2 and 3 are the active abrasive particles. Okay. If you see here, because of the viscoelastic nature of the medium, elastic nature, what is happening here is you can see the axial force along the direction of the applied pressure, at the same time radial force because of elastic component in the medium. Okay. In the previous slide it was just congested, so explanation might have not up to the mark. So, those people who have some doubts, they can see here what is happening is viscous component is generating the axial force and elastic component is generating the radial force. Okay. So, because of which what will happen is, assume that I have this particular surface. So, whenever my abrasive particle is like this, in that circumstances the radial force will indent like this and axial force will move, axial velocity will move here and FR will be there, because of which the shearing action will takes place. Okay. Shearing of the chip will takes place and the material removal will takes place. Okay. What about the inactive abrasive grains? This particular medium has three properties. Okay. One, it is self deformability. Second one is better abrasion and better flowability. Okay. So, these are the three main components of this medium. One is self deformability, better abrasion, and the third one is better flowability. flowing ability. Okay, these three requirements are there for this one. What is happening here is, if you have a self deformation, that means that if you make this particular medium, a semi solid medium, into a sphere and you put on a flat surface, with respect to time the atmospheric pressures can deform it. A human is not a self deformable body, because you are not deforming by the atmospheric pressures. You are standing, you are walking, you are running, but there is no deformation because of the atmospheric pressures. But if a fluid or a semi solid that you are making into a sphere and placing on a flat surface, after some time it is deformed by itself by the virtue of, or by the assistance of atmospheric pressure. That is nothing but the self deformation. If it is deformed by the atmospheric pressures itself, what will happen if you are going to deform with respect to extrusion pressure or the external pressures? So, whenever you are whenever you want to deform with respect to some external pressures, this medium itself is self deformable. So, if you are applying extra pressure, it will deform as per your requirement. That is the beauty about this process. The second thing is that it should better abrasion ability. That means that the abrasive particles that are there inside the medium are to be abraded against the surface to be finished, or surface across which it will flow, so that the microchips or nanochips can be generated and the surface finish can occur, and better flowability. So, it is having a self deformability, and now if you are going to put at certain pressure like 6 megapascal or 5 megapascal or 10 megapascal pressure, if you are putting through the hydraulic power pack, what will happen is it will flow to each nook and corners of the complex surfaces. That means that this particular medium can access or can flow across the complex surfaces and can remove the material as per the requirement of the customer, and you can generate or you can create the nano surface finish on that particular component. These are the three main properties of the medium. Whenever I will teach about the medium and its rheology, you may come across again. So, material removal mechanism, which we have seen here. So, viscoelastic nature is there, and the abrasive particle, as we have seen, this is the abrasive particle where you are getting the assistance from the viscoelastic polymers. So, viscoelastic polymers, if you see here, this is the axial force and this is the radial force, and this is the resultant force. Okay. Assume that I will say that it is a cutting force or something, okay, the resultant of this one. Okay. So, viscoelastic effect is there, because of which what will happen, these peaks will be sheared and you can get a good surface finish. Okay. After getting a good surface finish, you will achieve a critical surface roughness value for any type of finishing applications whenever you play with respect to input parameters like number of cycles, extrusion pressure, medium variables and other things. Okay. So, with respect to number of cycles, what do you mean by number of cycle? If you see the figure here, figure 1, what is means the medium is reciprocated like this. So, the medium from top cylinder, medium cylinder to the bottom medium cylinder is called one stroke, and if it is reciprocated back, that means that bottom medium cylinder to top medium cylinder, this is called one cycle. That means one bottom stroke and one top stroke, it is nothing but cycle. So, whenever assume that you are going to get the critical surface roughness at 100 cycles or 50 cycles, what that means is the change in surface roughness. That means that delta RA, if you are talking about central line average, the change in RA will be approx minimum or it is too less, then there is no meaning in going for more and more number of abrasive cycles. That means that number of cycles, if you are going to increase, that is enhances your input power, but there is no change in roughness. Okay. The change in roughness is nothing but initial roughness minus final roughness. Okay. This, if there is no much change in this value, then there is no meaning in putting extra energy into the system. That means that I am pressing or I am extruding across the surface to be finished by the extrusion pressure. Extrusion pressure, where it is coming? You have to give input power to the hydraulic power pack. So, that means that your input energy is there. If the change in roughness is good, you have to give extrusion pressure. If the change in roughness is not much, then there is no meaning in giving the extra or external energy. For that purpose, whenever you achieve the critical surface roughness for any particular surface, then you can stop the finishing process. So, basic elements of abrasive flow finishing, one is a machine setup, that is nothing but the experimental setup, which is hydraulically operated cylinders used for back and forth motion of abrasive putty and the pistons as well as medium cylinders, and all these things will cover into the machine setup. Then the tooling. So, tooling is nothing but it is the workpiece fixtures basically. If at all I want to finish a knee implant, my fixing devices are holding the knee implant so that medium has to flow across the surface uniformly. So, this particular is nothing but the fixture or the tooling. Assume that I want to finish a hollow cylinder, you required minimum tooling. If at all I want to go for finishing of a knee implant or a hip implant and other things, what will happen is your fixture will be different. That is nothing but the tooling. So, tooling will vary for component to the component. The medium, abrasive medium is a pliable material resilient enough to act as a self-deforming grinding stone when forced through the passageway. It consists of basically base polymer materials, abrasive particles and rheological additives such as plasticizers, hardeners and so on. These are the some of the constituents of the medium that is used in the abrasive flow finishing process. Abrasive flow finishing process basic elements, the first element is machine tool. Okay. This is a machine tool drawing. If you want to develop your own, the dimensions also given. This is the laboratory scale development that is done, and it has a various motions also, so that you can accommodate a different size and shape component. Okay. So, this is the main support on which you are mounting. Basically, this particular drawing that we have done for a radial drilling machine. So, this particular support is came from the radial drilling machine. We have replaced the system, other systems with respect to the medium cylinders. This is the upper medium cylinder and upper piston, upper hydraulic piston. This is the lower medium cylinder and lower piston, lower hydraulic piston. Then you can connect this upper hydraulic piston and lower hydraulic piston to the hydraulic power pack, which is not given in this particular picture, and you can reciprocate it. Whatever is missing here is the medium is not placed in the medium cylinders. These are the medium cylinders, 2 medium cylinders, and the tooling has to be placed in this one so that it can be finished. These are the different things that are not included. But if you see the various motions of this one, these motions are given. Vertical motion normally 1 to 310 mm. So, that means that the maximum component you can hold with easily is 300 mm height component you can hold. At the same time, you can see the y axis and other axes motions, and you can also see this particular upper medium cylinder set to 180 degrees, because if at all I want to hold the abrasive medium, if at all I want to hold the workpiece with the offset, that means that assume that I want to hold this type of tube to be finished, what will happen? I need to rotate the upper medium cylinder here, so that it will come here, my lower medium cylinder is here. Okay. So, that is the possibility of this particular motions that are given to this abrasive flow finishing process to make it as a flexible to finish different kinds of workpieces. So, this is about the experimental original picture. Whatever you have seen in the previous slide is the schematic drawings. This is the experimental setup where you can see the lower medium cylinder, upper medium cylinder, upper hydraulic cylinder, lower hydraulics. This is lower hydraulic cylinder and the hydraulic power pack, everything is there, and these are the pistons which will try to push the medium and you can get the finish. Okay. So, whatever is missing is here is the fixture and medium. Medium both are missing. Okay. So, these two elements we will see in the upcoming slides. So, the second one is tooling or the fixturing. If you see here, assume that I want to finish this particular component. So, I need to give the tooling as per the requirement. Okay. So, used to confine the direct flow of the medium appropriate areas, that means that it has to guide the abrasive medium across. The abrasive medium, as I said, it is a semi solid medium, it has to flow across the surface to be finished. When it will finish? If it can flow across the surface uniformly, then uniform surface finish can be generated. Okay. So, the tooling function is it has to guide across the surface to be finished, so that it can achieve the uniform surface finish. To selectively permit or block the flow of media into out of workpiece passages where the deburring, radiusing and surface improvement is required. That means that it has to permit to the regions where it has to finish only. It should not go into the other regions. The passages of similar nature are processed in parallel. You can go for many things and replaceable inserts. Now, we have seen the one of the element of abrasive flow finishing process, that is experimental setup or the AFM machine setup. Okay. So, now we are going to see the second element, that is called tooling or fixturing. The basic function of the tooling or the fixture is to hold the workpiece in position and makes the medium to flow across the cross sections to be finished. Okay. So, how it will do? So, to tooling and its functions, if you see the selectively and controllability, that means that it has to select locations of the workpiece so that the medium flow across that particular section only, and controllability. So, it has to flow uniformly under the control of this particular fixture, and it should confines and direct the flow of abrasive medium across the cross section to be finished. Okay. So, it has to confine to that particular sections of the workpiece only, and it has to direct. So, how we will see in the picture, this is the small turbine or impeller blades that has to be finished. So, how to finish only the turbine blades, not the other particular parts. So, it has to finish these particular portions, not the other portions that are covered with a sky blue color one. Okay. So, that means it is masked to not to finish this particular portion, and it has to finish only this particular part. For that purpose, you need the proper tooling. At the same time, you need to have proper radiusing on the tooling and other things. Okay. If you can see here, there is a radiusing that is provided on this surface, so that the medium will freely flow on the surface and it will direct towards the finishing of this turbine blades or the impeller blades. These are the workpiece that is to be finished initially. This is the one that to be finished, and this is kept here. So you can keep it and you can put the fixturing, and you can also place the medium initially, and you can start the finishing process. This is nothing but the tooling or fixturing. Okay, this is the measure, and you can see the before and after finishing. The before finishing it is 1.75 microns, and after finishing it is 0.4 microns. This is how the casted blades can be finished. Okay, so hope you understood now what is the function of the tooling or the fixturing is to hold the workpiece firmly, at the same time to direct the medium across the surface uniformly and controllably to finish that particular section only, not the other sections. If you see the other things of the tooling and fixturing, it is used to confine and direct the media flow to the appropriate areas of finishing, selectively permit or the block the flow of media into out of the workpiece passages. That means that it should not pass the media out of the workpiece passages. That means that it has to direct only to the surfaces, and deburring, radiusing or the surface improvement is required. That means that it can do. Okay, so it should not makes the medium to move out of this confined regions. The passages of the similar nature are processed in parallel. That means that you can finish the many holes or many parts in a single go by using the proper fixturing. Replaceable insert, that means that you can go for nylon, Teflon, hardened steel, this type of replaceable inserts you can go, so that you can stop the media or the restrict the media flow to not flow to the restricted regions. For non-uniform x-axis MRR, narrowest section is minimum and the widest section is most, that you can see here. And tooling for a abrasive flow finishing or abrasive flow machining is designed in two aims: to hold the workpiece in the position and to direct the medium flow. This is what I was discussing in the previous slide also. Okay, so the tooling, suppose I want to finish a cylindrical workpiece. For that purpose, what normally you can go is, you can have a cylindrical workpiece and you can, this can be a fixture, and to understand, make you to understand, we have put this particular thing, and this can be a the outer diameter and this can be a inner diameter. Okay, so that medium flows in the finishing region only. Okay, so that you can finish the internal surface of the hollow cylinder, and you can use this particular cylinder in various applications. So similarly, the fixturing also can be done for the finishing of bevel gears and other things. So the bevel gear, you can hold the bevel gear in this direction and you can send the medium, so the medium can flow across the teeth and other surfaces, so that it can do the deburring operation as well as finishing operation in the bevel, on the bevel gear. Okay, so if at all I want to finish a flat surfaces, assume that this particular is my workpiece and I want to finish it, because till now you have seen it is a cylinder and other bevel gears and other things. What about the flat workpieces? You can also accommodate these things in a hollow cylinder. How to accommodate? If you see that you have the these type of workpieces, so you can see this is the after finished workpiece, after AFF process. You can see the mirror surface finish on the workpiece. The same thing is given here in a schematic way. So how to hold this one? So for that purpose, you will have, one is the fixture plate and the locking plate. Okay, this is called the fixture. It is a part of the fixture, that is nothing but where the fixture you can say, and this is the locking plate. Okay, so this is the workpiece. So you just place the workpiece in this regions, two workpieces you can place. Then you can put this locking plate. There will be two locking plates. One will fit at the bottom, another will fit at the top, so that these portions will be locked from the both bottom and top, so that the workpiece will stay there itself. As you can see here, this is how the workpiece is engaged. Okay, so sometimes you should make sure that both are the same size. This particular picture is provided to make sure that, to show how the workpiece look like. At the same time, you can have like this also, or you can make the height of the workpiece so that it will sit within the circle. Then the uniform surface may also will takes place. If the protrusion is there, it will still okay for the laboratory purposes, but if at all you want to go for commercial purposes and other things, you should have within the circle, so the uniform surface finish will be occurred. The same thing explained in the schematic way, and in the three-dimensional and orthogonal views are shown. This is the isometric view, and these are the two front view as well as the top views. Okay, so this is how the tooling holds the workpiece. At the same time, it will allows the medium to pass through. This is the medium which will pass through across these surfaces. Okay, this is not only finishes your workpiece, but also finishes your fixture also, that is which is exposed to the finishing region. So we have seen the two elements. One is the machine setup as or the machine tool, then the fixturing or the tooling. Now we move on to the third and main element of this abrasive flow finishing process is the abrasive medium. Normally some people it is called as the polymer rheological abrasive medium, where you will have polymers, rheological additives as well as abrasive particles. That is why this particular medium comprises of these three elements. That is why it is called polymer rheological abrasive medium. Or people, if you are going to use very low viscous fluids, then it is called as polymer rheological abrasive fluids also. Okay, so this particular medium is a semi solid to a liquid phase. That is why you can call it as a medium, you can call it as a fluid. At the same time, the plural for medium is media. So you can, many people works on this particular area for their PhD research, master's research and other things. Okay, so those people who are interested to take up this abrasive medium as their research, it is well and good. So our group also works extensively in this particular area. So the medium, most important and critical component of this particular abrasive flow finishing process is nothing but the medium. Okay, so the medium, this is one, what are the picture is taken from extrude hone, which is nowadays it is called Canametal extrude hone. So it will have the base polymers, that is nothing but viscoelastic polymers with rheological properties and fine abrasive particles. Okay. So what is the rheological additives that normally people will use it in this particular thing is, many types of viscoelastic polymers are there, but commonly used is polyborosiloxane. So many of the companies which commercially produces this particular polymer is one of the best example for viscoelastic nature material, and this particular material is blended along with so many rheological additives such as softeners, plasticizers, hardeners, functionalizers and so on. If you are going for low viscous type of thing, then they are going to add the functionalizers for holding the abrasive particles in the location. That is, many additives are using. So one can explore so many varieties of rheological additives. Apart from it, people also uses some of the chemicals for having this particular material for long period without affecting the bacteria or any type of microbes. Okay. So, as I said, medium should possess majorly three things that we have discussed in the previous slides also. So, the deformation, self deformability, better abrasion and better flowability and other things you can see here. This is one of the complex thing that is finished here. So, you can see the medium flow, how the medium is deforming itself. In this particular section, if you see how the medium is deforming as well as it is flowing across the section to be finished, and the medium look like abrasive particles are blended with polymers. Okay. So, there are multiple varieties of the medium. Normally, there are high viscous medium, medium viscous medium as well as low viscous medium. So, two examples that we are seeing here, that is called low viscous medium and high viscous medium. So, if at all I want to abrade uniformly, then people has to go for the high viscous medium. Okay. In a high viscous medium, whenever you are extruding, that means that whenever you are applying the extrusion pressure from one direction, what will happen is this medium is so high viscous that it will extrude through the hole. For example, I am telling it is a hole that is drilled by EDM process or laser beam machining process or any other process. So, you are just putting some pressure, this pressure extrudes the medium across the surface to be finished and comes out as a straight medium slug. Okay. Medium slug is nothing but it is a medium that is coming out as a single entity. Okay. If you are applying extrusion pressure, what will happen? The viscosity of the fluid is so low that it comes out as like this. Okay. So, because of this, what is happening is, if you have sharp edges, you can do the radiation. So, people, you may know what is chamfering, because chamfering will be normally given on the sharp edges to protect or to give safety to the operators, okay, or the customers. For the same thing, you can give radiation by using this one, because your medium is coming out like this, coming out like a flower. How the flower will come? So, like that it is coming, then it is going. So, for example, if you see water, if you switch on or if you just rotate, if you on the tap, what will happen? Your water slightly comes in a divergent way. Similarly, because your water is low viscous fluid, similarly if you are going for a low viscous medium, there will be a divergence and there will be a medium will come out like this, and because of that, if I have a hole like this, sharp edge, and low viscous medium comes and it will become the radiusing. Okay. So, this particular thing will become radiusing. Okay. So, whenever you get a particular component like this, and it will be always safe for the people. Okay. So, this is called radiusing. So, that is the beauty about this particular process, especially whenever you are using low viscous medium. For finishing as well as slight radiusing applications, you can have a particular medium in between this low viscous and high viscous medium. That is what you can see in the figure. This particular figure is, this is high viscous medium, this is medium viscous medium and low viscous medium. Okay. So, let me write for your understanding, this is high viscous medium, this is medium viscous medium, and this is low viscous medium. So, red on red it may not be visible, that is why I am writing at the bottom. So, this is a low viscous medium. So, you can have three common varieties that is supplied by Canametal extrude hone. You can purchase it, but the basic problem with this particular medium, which I cannot say the base problem or something, but is the medium is too expensive for an a developing nation like India, at the same time you have to discard this particular medium after whenever it reaches to 10% of its original weight. That means that, as you might have seen the tool life of a single point cutting tool, whenever you say the tool wear exceeds or the flank wear land exceeds 0.5 micron, 0.5 mm, or that means 500 microns, then you have to discard. Similarly, the tool life or the medium life of this particular medium is whenever it exceeds 10% of its original weight. That means I am purchasing 1 kg of the medium, that means that 1000 grams, whenever it exceeds by 1100 grams, that means that you have to discard. So 100 grams of chips or the microchips or the nano chips embedded inside the medium, so you have to discard. Because of this, there may be scratches that one can generate on the surface. That's why the life of a medium can be expressed in these terms, like whenever you have 1000 grams is weighing 1100 grams after 100 experiments or 200 experiments or any type of, after finishing 10 samples or 100 samples, whatever it may be. So if your weight is increased, that means that 10% of foreign elements or the foreign body materials are embedded inside the medium, then you have to discard. That is about the life of the abrasive flow finishing medium. So you can see the medium normally. So the medium having lot of abrasive particles which are there in the polymer rheological abrasive medium, where you have polymer, where you have rheological additives and abrasive particles. Okay, so these are the 3 varieties of things are there. Polymers, normally these are solids or semi-solids. Rheological additives will be liquids mostly, as well as some of the solid particles, and abrasives will be solid or the ceramic particles. Okay, this particular thing is a combination of liquids and solids mostly. So this is a two-phase medium where you can have interaction between the different things. Okay, so if you can see here, if you can enlarge the medium to see how the abrasive particles are held in the polymer networks. If you see here, this is an abrasive particle, how it is blended, at the same time how it is staying inside the medium. It can have many possibilities, like polymer and abrasive contact can be one of the, at the same time abrasive to abrasive contact is another thing, and it also can have many other things. Agglomeration is also some of the problems. You can also see there will be agglomeration of these particular things in some locations. At the same time there will be voids also. If your medium viscosity is slightly higher side, then there will be a chance of voids in the medium also. Okay, so if you see the grinding wheel also you need structure. So structure means you should have closed or open structure. So if at all you want to go for a open structure, that means that your void should be present. At the same time the abrasive to abrasive distance will be slightly higher. So you can designate this abrasive flow finishing. Somebody want, they can do this particular also, how to specify a abrasive flow finishing medium and other things. You can also work on it. So the many people thinks about how the abrasive particles, which are the solid particles, will stay inside the abrasive polymer rheological complex medium. Okay, polymer is a semi-solid to solid or semi-solid to liquid. Rheological additives mostly liquids. At the same time you have semi-solids also or the powders also. In this particular complex, where is the abrasive particles are sitting? That is one of the biggest challenges to understand. For that purpose, so the commonly thing is that the polymer networks are dimensions are approximately nanometers, but at the same time your abrasive particles are in approximately like 50 microns to 100 microns, like that. Okay. So how it will work? So normally your polymer networks will be there which are binded. At the same time you are going to use rheological additives to hold it. So this particular thing is a big chemistry to understand, and if you can see how the polymers as well as rheological additives are blended and which part of the chemical of this polymer is attaching to the rheological additives, which part of chemical bonds of the rheological additives, then how these things are attaching to the silicon carbide or Al2O3 or these type of abrasive particles, and all those things can be a good study. So you can see here the medium and a gross spectrum. At the same time you can see in a close-up view also in the second slide. Figure 1 shows the abrasive particles as well as the chips. Okay, and if you zoom it up you can see the figure 2 where you can see small the fragments of the workpiece. This particular medium having lot of polymers, plasticizers, other rheological additives along with the silicon carbide particles. Okay, these silicon carbide particles are getting help viscoelastically from the various rheological additives, and they finish the workpiece material. The workpiece material here is the pure aluminum material. That's why you can see the chips in a shining way. Okay. So not only that, if you can see clearly the abrasives also, if you are going to use multiple times, the abrasive particles also become blunt. Okay. This is another phenomena. Sharp edges of the abrasive particles will become blunt because you are going to use this particular abrasive particles for hundreds and hundreds of cycles, like 200 cycles or 300 cycles or 400 cycles. You depend on your requirement and depend upon your initial surface roughness and other things. Okay. Not only that, you can also see some of the brittle fractures on the abrasive particles, and you can clearly see these are the microchips or the nano chips that are evolved from the finishing region, and these can go and blend with respect to the polymer rheological abrasive medium. And if you are going to increase again and again, what is going to happen is the medium weight will increase. As I said in the previous slide, that if the medium weight, which is assumed that you are going to have 1 kg, that means that 1000 grams, if it is going to 1100 grams, you have to discard. This is how the medium weight will increase. Okay. So at the same time, one has to note here also is that the sharp edges of the abrasive particles will also become blunt. Okay. This is the literature that says is that when it is increased by 10%, you have to discard. This also is one of the thing from the point of blunting of the abrasive particles. So the researchers might have seen that the abrasive particles might have blunt by the time. Okay, because it is already removed so much material. That means the summary of this particular class, what we have seen is we have entered into the advanced abrasive finishing processes, and we took the first and foremost and highly important process, that is called abrasive flow machining and abrasive flow finishing process. Why it is called as abrasive flow machining process and abrasive flow finishing process? Since this abrasive flow finishing process uses a semi-solid to liquid type of cutting tool, this is mostly used for those internal holes where the intersection is there and burrs are there. So for mostly it is used in 1960s to 70s to 80s for deburring applications, because your solid cutting tools cannot penetrate into those complex regions. For that purpose, liquid tools or the semi-solid tools are fabricated, and these are used for deburring application. That means that the removal of burrs that are formed in internal complex regions. That's why this particular process in initial stages is called as abrasive flow machining process. Later on, people are using it for the nano finishing applications. That's why this name is amended again to abrasive flow finishing process. Okay. So, the abrasive flow finishing process, we have seen the material removal mechanism initially with respect to viscoelastic medium, how the forces are generated whenever the extrusion pressure is applied. What is happening here is you have an axial force and axial velocity, because both are in the same direction of applied extrusion pressure, and the radial force and radial velocity perpendicular to that axial directions. But since the indentation velocity is so low compared to axial velocity, that is why indentation velocity will be neglected. Then we move on to the various elements of the abrasive flow finishing process. The first element is machine setup, where you have a lower medium cylinder, upper medium cylinder, lower hydraulic piston, upper hydraulic piston, and which is connected to a hydraulic power pack that supplies the hydraulic fluid, so that the medium can be reciprocated using this hydraulic system. Then we move on to the second one, that is called tooling or the fixturing. The main function of the tooling and fixturing is to hold the abrasive particle intact in that particular location and to direct the medium across the surface to be finished, and it has to direct uniformly and controllably. The third and most important thing is abrasive flow finishing medium or polymer rheological abrasive medium, where you have polymers, where you have rheological additives, where you have abrasive particles. The combination of polymers, combination of rheological additives, combination of abrasives gives the name polymer rheological abrasive fluids or polymer rheological abrasive media. So, media stands for plural of the medium. Okay. So, the medium is a most crucial, and when you have to discard, because you are familiar about the tool wear. So, what is you are familiar with respect to tool life. So, what is the life of this abrasive flow finishing media is that you have to discard whenever the medium exceeds 10% of its weight by having lot of chips in the medium. Okay. These three elements we have seen, and we will see in the next class about the few more details about abrasive flow finishing process. We enter into the types of abrasive flow finishing process and material removal mechanism in detail, and applications, advantages, and some of the rheological characterization for the abrasive flow finishing medium. This all we will see in the next class and the second part of abrasive flow finishing process. Thank you for your kind attention.